Now, in the last lecture, we have discussed about the product of vectors. Now, let's take the example which is based on this. For any two vectors, A vector and B vector, prove that first thing, magnitude of A vector plus B vector whole square is equal to magnitude of A vector square plus magnitude of B vector square plus 2A vector dot B vector. Second, magnitude of A vector minus B vector square equal to magnitude of A vector square plus magnitude of B vector square minus 2A vector dot B vector. Magnitude of A vector plus magnitude of B vector square plus magnitude of A vector minus B vector whole square is 2 times of magnitude of A vector square plus magnitude of B vector whole square. Now interpret the result is geometrically. Interpret the result geometry. Both magnitude of A vector plus B vector is equal to magnitude of A vector plus magnitude of B vector. So A vector is parallel to B vector. Now magnitude of A vector plus magnitude of B vector whole square is magnitude of A vector square plus magnitude of B vector square. A vector B vector are orthogonal. Let's see the solution of this. Now first is magnitude of A vector plus B vector whole square is, now we can write like as A vector plus B vector dot A vector plus B vector dot A vector plus B vector dot B vector, that is magnitude of A vector square plus B vector dot A vector plus A vector dot B vector plus magnitude of B vector square. Magnitude of A vector square plus magnitude of B vector square. Now we know that the A vector dot B vector equals to B vector dot A vector. So this one we can write like as a 2 times of B vector dot A vector or the A vector dot B vector. Now second one is similar to the first one. A vector minus B vector magnitude square is, we can write like as A vector minus B vector dot A vector minus B vector. So this is magnitude of A vector square plus magnitude of B vector square minus 2 times of A vector dot B vector. Now third, now add the first result and the second result. So magnitude of A vector plus magnitude of B vector square plus magnitude of A vector minus magnitude of B vector. Now adding both these, then it will be subtracted, then we get 2 times of, then the magnitude of A vector square, then the magnitude of B vector square. So now in this we just the examiner we have given to this interpret by the geometrically. So now let's make the parallelogram A, B, C. That one is A vector, B vector, so it is also B vector. Now join A to C. So now we know that the AB vector plus BC vector is equal to AC vector. So A vector plus B vector equal to AC vector. Now in the triangle ADB, AD vector plus DB vector equals to the AB vector. So now the DB vector is A vector minus B vector. Now the A plus B vector and the A minus B vector represent the two diagonals of the parallelogram. So now the magnitude of A vector plus the magnitude of B vector whole square plus the magnitude of the A vector minus B vector whole square is the 2 times of the magnitude of A vector square plus the magnitude of the B vector square. Now the next one, in the next one, fourth question is asked the A vector plus B vector is the magnitude of the A vector minus B vector equal to the magnitude of A vector minus B vector. Now squaring on both the sides, then we get the magnitude of A vector square, magnitude of B square squaring, then 2 times of A vector dot B vector is equal to the magnitude of A vector square plus magnitude of B vector square minus 2A vector dot B vector. So by the solving this we get the 4 times of A vector dot B vector equals to 0. So A vector dot B vector equals to 0 means the A vector is perpendicular to the B vector. Now in the next question is asked the A vector plus B vector, magnitude of A vector plus B vector is the magnitude of A vector B vector. So now in the next result is proved the A vector magnitude of A vector plus B vector is the magnitude of A vector plus magnitude of B vector means the A vector and the B vector are parallel. So how can we prove? Now again squaring on the both sides. On both sides. So by we get magnitude of A vector square plus magnitude of B vector square plus 2A vector dot B vector. So that one is magnitude of A vector square plus magnitude of B vector square 2 times of magnitude of A vector magnitude of B vector. So A vector dot B vector is equal to the magnitude of A vector magnitude of B vector means the cos theta equals to 1 means the theta equal to 0. So A vector is parallel to B vector. Now the last one is magnitude of A vector plus magnitude of B vector square is equal to the magnitude of A vector square plus magnitude of B vector square. Now this one we can write like as the magnitude of A vector square magnitude of B vector square plus 2 times of A vector dot B vector equals to the magnitude of A vector square plus the magnitude of B vector square. So 2 times of A vector dot B vector equal to 0 means the A vector and B vector are orthogonal. Now let's take the next example. For any two vectors A vector and B vector, prove that magnitude of A vector plus magnitude of B vector is less than equal to magnitude of A vector plus magnitude of B vector. Now let's see the solution. Magnitude of A vector plus B vector square is magnitude of A vector square plus magnitude of B vector square plus 2A vector dot B vector. So now magnitude of A vector square plus magnitude of B vector square, this one we can write like as 2 magnitude of A vector magnitude of B vector cos theta. Now cos theta is less than equal to 1. Now cos theta is less than equal to 1. So now by solving this we can equate to each other by so by this the now cos, we know that the cos theta is less than equals to 1. So now the 2 times of the magnitude of A vector magnitude of B vector cos theta is less than equal to the 2 times of the magnitude of A vector magnitude of B vector. Now the magnitude of A vector square magnitude of B vector square plus 2 times of the magnitude of A vector magnitude of B vector cos theta is less than equal to magnitude of A vector square plus magnitude of B vector square 2 times of the magnitude of A vector magnitude of B vector. Now that one is a magnitude of A vector plus B vector whole square is less than equals to the magnitude of A vector plus magnitude of B vector whole square. So the A vector plus B vector is less than equals to the magnitude of A vector plus magnitude of B vector. Now let's take the next example. Prove Cauchy-Schwarz inequality. A vector dot b vector whole square is less than equals to the magnitude of a vector square magnitude of b vector square, and hence show that a1 b1 a2 b2 a3 b3 whole square is less than equals to a1 square a2 square a3 square b1 square b2 square b3 square. Now let's see the solution. A vector dot b vector equals to magnitude of a vector magnitude of b vector cos theta. Now a vector dot b vector whole square is magnitude of a vector square magnitude of b vector square cos square theta. Now again take this condition, cos theta is less than equal to 1. So now again multiply both the side is magnitude of a vector square magnitude of b vector square cos theta. Now this side is also magnitude of a vector square magnitude of b vector square. Let's consider the a1 vector is a vector is a1 I cap, a2 j cap, a3 k cap, and the b vector is b1 I cap, b2 j cap, b3 k cap. So now a vector dot b vector is a1 b1, a2 b2, a3 b3. Magnitude of a vector square is under root of a1 square, a2 square, a3 square. Magnitude of b vector is b1 square, b2 square, b3 square. So now put these things to there. So by this we get a1 b1, a2 b2, a3 b3 whole square is less than equals to a1 square, a2 square plus a3 square, b1 square plus b2 square plus b3 square. Let's take the next example. If two vectors a vector and b vector are such that magnitude of a vector is equal to 2, magnitude of b vector equals to 1, and a vector dot b vector equals to 1, find 3a vector minus 5b vector dot 2a vector plus 7b vector. Now solve this. Now the 3a vector minus 5b vector is dot product with the 2a vector plus 7b vector. So now it is 6a vector dot a vector plus 21 a vector dot b vector minus 10 b vector dot a vector minus 35 b vector dot b vector. That is 6 times of magnitude of a vector square plus 11 times of a vector dot b vector minus 35 magnitude of b vector square. Now that one is 6 into 2 plus 11 minus 35 into 1 square. By the solving this we get 6 into 2, that one is 2 square is 24 plus 11 minus 35, so that is 0. Now let's take the example. Show that the angle between two diagonal of cube is cos inverse of 1 by 3. Now let's see the solution. The diagonal of the OP, now the OP vector is cube is AI cap, AJ cap, AK cap. Now let's form the cube. Now this one is B point, this one is O, Q, A, S, P, C, R. Now this one is origin. This point is A comma A comma A. This one is A comma 0 comma 0. This one is 0 comma A comma 0. Or this point is 0 comma 0 comma. So now the AR vector is the position vector of R minus the position of A. So by this we get minus AI cap plus AJ cap plus AK cap. Cos theta is OP vector dot AR vector magnitude of OP vector, magnitude of AR vector. So now cos theta is minus A square plus A square plus A square upon root 3A into root 3A. By this we get 1 by 3. So cos theta is 1 by 3. Now in the next lecture we will discuss the vector or cross product.